Alright, so we are told Roger sees water balloons fall past his window. He notices that each balloon strikes the sidewalk 0.83 seconds after passing his window. Roger's room is on the 3rd floor, 15 meters above the sidewalk. How fast are the balloons traveling when they pass Roger's window? And assuming the balloons are released from rest, from what floor are they being released? And each floor of the dorm is 5 meters high. So I have a little picture here. So this is a building. This is floor 1, 2, and 3. This is Roger's floor. This distance is what the balloon falls. It's 15 meters. It takes 0.83 seconds. So let's write out the constants now. So delta y equals negative 15 meters. Negative because it's going to be going down. Our t equals 0.83 seconds. And our acceleration due to gravity equals negative 9.8 meters per second squared. So now we have 3 constants, which means that we can use our equation. So let's use the no VF. So delta y equals v naught t plus 1/2 at squared. Negative 15 equals v naught times 0.83 plus 1/2 negative 9.8, 0.83 squared. So let's plug that into our calculator. So 0.5 times negative 9.8 times 0.83 squared. So it gives us negative 15 equals v naught 0.83 minus 3.38. Now let's add this to both sides. So negative 15 plus 3.38. This gives us v naught times 0.83 equals negative 11.62. Now divide both sides by 0.83. So divide this by 0.83. This gives us v naught as negative 14 meters per second. So that's our answer to part A. When it's past his window, so negative 14 meters per second. So now it says that the balloons are being released from rest a couple floors above. So we can draw that out like this. So we don't know how many floors it is, but we know that up here it's going to be 0 meters per second. Here it's going to be negative 14 meters per second. And the distance we don't know, but we can make a different situation where our delta y equals, we don't know, our v final equals negative 14 meters per second, v initial equals 0 meters per second, and acceleration due to gravity equals negative 9.8 meters per second squared. So this one, we can use the no delta x equation to solve for time. So v final equals v naught plus at. So negative 14 equals 0 plus negative 9.8 times t. Let's do some math. Negative 14 divided by negative 9.8. This gives us t equals 1.43 seconds. So that's saying that in order for the balloons to drop from the very top to his window is 1.43 seconds. So now that we have time, we can actually use a different equation where we can solve for the delta x. So delta y equals v naught t plus 1/2 at squared. So delta y we don't know. So delta y equals, but our v naught is 0 plus 1/2 negative 9.8. And our t is 1.43. We square that. So we can do some math here. 1.43 squared times 0.5 times negative 9.8. And this gives us our delta y to be negative 10 meters. So now we have 10 meters, but that doesn't quite give us our how many rooms above are. So if each dorm is 5 meters high, then that means that 10 meters is just going to be 2 floors. So this right here, 2 floors. So this is going to be 1, 2, 3, 4, 5. 5 floors is where it starts from and falls. And that is the answer to part B. So 5 floors high.